so we have already done multiplication of scientific notation, right? We've already done division of scientific notation. Okay, what we're doing today is addition and subtraction of scientific notation. Now, normally we would do addition and subtraction first, but this one's a little trickier, okay? The first thing I got to, actually, I'm going to put a couple of these up here, and I want you to do this for a warm-up. Do this one and then do this one. Okay, do these two problems for your warm-up. I know. There you go. Okay. I'll give you about 2 minutes. Okay, I don't mind if you use calculators for the decimal part. That's fine. You're going to be able to use calculators today. Okay, the thing to keep in mind, very, very important. Okay, you're going to use this today as well. Okay, this is your chart. If your decimal moves left, what happens to your exponent? If it moves to the right, your exponent goes down. Left, up, right, down. Okay, you guys are definitely going to want to have this memorized for your test on Thursday. Okay, so somebody tell me what you did first on the multiplication of these. I put some of these on the worksheet today, so you're going to need to remember how to do these. Somebody tell me what to do first. What do I multiply first? Okay, so I'm going to multiply 2.3 times 9.8. And if I multiply 2.3 times 9.8, what do I get? Okay, so 22.54. And then if I multiply bases that have the same exponents, what does that mean? I add 5 plus 7, which would give me what? 10 to the 12th. Now, what is wrong with this answer? It's not quite where? Scientific notation. So how do I get this answer to be in scientific notation? Levi?
Move the decimal to the left.
Okay, if I move it here, now I have 2.254. And what's my rule if I move left? My exponent goes where? Up. Okay, so if I move to the left, my exponent goes up from 12 to what?
13.
To 13. So this would be 10 to the 13th power. Good. Who got that one correct? Very good. Okay, let's do the second one. Okay, I'm going to divide 3.6 by 91 first. So if I do that, what do I get? We'll just round that to, we'll say 0.0039. 0.0039. And what's my rule if I have the same exponent, same base? What do I do with my exponents if I'm dividing? Anybody? Noah? No, you don't add if you're dividing. What do I do with my exponents if I'm dividing? Hannah?
You just subtract.
You subtract them. Good. So this is times 10, negative 5, minus, what's this? Negative 3. Now, what do I need to keep in mind if I'm subtracting and it's not normal? Copy what? Copy at opposite. So this is negative 5 plus 3. What's negative 5 plus 3? So I have 0.0039 times 10 to the negative second power. But I'm still not done. Why? Because what's wrong with my decimal? It's not in scientific notation. So, Samir, how can I do that? What do I need to do? 1, 2, and I could stop here. Why? Because this number needs to be what? Between what? 1 and 10, right? So 3.9, I moved it 3 places. Which direction? If I go right, what happens to my decimal? It goes, my exponent goes down. So I went right 3 places, so I go back down from -2 back down to where? -5. Okay, good. How many of you got that one correct? Okay, good. That stuff is going to be on your test, so make sure you understand that, okay? All right. So what we're going to do today, we're going to continue with operations of scientific notation, except we're going to add and subtract them. Now, these are a little bit different, okay? If I have 2 fractions, and I'm going to add 2 fractions together, what do I have to have in order to add 2 fractions together? Okay, look, if I was going to add this,
The same denominator.
what would I have to have?
The same denominator.
I would have to have a denominator that's the same, right? And I would have to get these 2 so that they are the same. Well, it's kind of the same thing with addition and subtraction, okay? In order to add or subtract, scientific notation, okay, you must have the same exponents. It's kind of like a common denominator. Okay? Does that make sense? So if I have something like this, let's say I had 8.21 times 10 to the 5th, and let's say I'm adding to that 2.4 times 10 to the 3rd. Okay? Well, what's wrong with this? Why can't I add these together? Levi?
The exponents are the same.
Yeah, this exponent needs to be the same as this exponent. Okay? Well, how do you think I can get them to the same? I can either take the 5 down, or I can do what? Take the 3 up. Okay? I'm going to tell you that it's usually easier if you take the smaller exponent and move it up. Okay? Are you writing this down?
Yeah.
Are you writing this down? Are you writing this down? Okay. So I'm going to take 8.21 times 10 to the 5th. That one's going to stay the same. But this, if I move this up to 10 to the 5th, okay, go back to my rules. Okay, if I go up, if my exponent goes up, where's my decimal going? Left. If my exponent goes down, where's my decimal going? Right. Okay. So I went from 3 and I went to 5. Did I go up? I went from 3 to 5. Did I go up? Yeah. So if I went up, how many did I go up? I went 2. So my decimal is going to go where? 2 spaces which direction? To the left. Okay. So this 2.4 is going to move 1, 2. This is now going to be 0.024 times 10 to the 5th. Okay. Now I'm in good shape. I can simply put these together. So I'm going to add this and this, 8.21 plus 0.024. Go ahead and do that. And what do you get? 8.234. Okay. Now, am I multiplying these 2 exponents? No. And think about this, guys. If I added 1/4 plus 1/4, what would I have? 2/4. Did I add my denominator there? It stayed the same. So the same rule applies for my exponent. This exponent stays the same because they're common now. So this is going to be 8.234 times what? 10 to the 5th. That's going to be my answer. Okay. Does that make sense, what we did? Yes, Levi?
Why is it 10 to the 5th?
Well, because you're not multiplying the exponents or dividing them. Okay, so I'm not going to add the exponents. I'm just taking 2 numbers and putting them together.
If they're the same, you just bring the same number down.
Once you have a common exponent, then you just keep it the same. Okay? And I can show you why if you'd like. Let me do all this and then I'll show you why. Okay, I'll show you, like, I'll evaluate and show you why. Yes?
So when the second exponent is smaller, then do you usually match it with the second? Like it's three.
A good rule of thumb is to just always take the smaller exponent and move it up to the larger one.
And yeah, it has to be the same.
Has to be the same, yeah. All right, let's try another one. Can I erase this? Everybody got this? Kemper, did you get all that?
Yeah.
Okay. All right, let's try this one. Let's say I have 9.7 times 10, let's say to the 7th, and I'm going to add, let's say 6.3 times 10 to the 5th, okay? What's the first thing I should do here? First of all, is this one going to change at all? This one's going to stay the same, isn't it? Okay, so this is 9.7 times 10 to the 7th. Now this one is going to change because this 5 needs to become a what? So if I go up 2, I'm going to go where? Left 2, right? Okay, so this is times 10 to the 7th. I move this 2 places. What's that going to give me? 0.063. Okay, can you take it from here?
Yeah.
What are you going to do?
Add 9.
Add these together. What do you get? 9.763 times 10 to the what? 7th. Okay? It's not that difficult, is it? All right, so now let's try subtraction. Okay? Can I erase this?
No.
Okay. Tell me when you guys have it.
Do you multiply 9.7 times 0.063?
No, you add them together. Yep. What's your question?
Never mind. Okay.
All right. Yes.
How did you get to 7.63?
You add this plus this. Okay. All right, let's try another one. Are we good on addition, or can we move on to subtraction? Yes? If not, it's okay. We don't have to. Are we good?
Yeah.
Hannah?
I'm still like having a little trouble understanding.
Okay, let's try another one. Let's try this one. Let's say I've got 7.1 times 10 to the, let's say, negative 4th. And I'm going to add to that, let's say, 4.9 times 10 to the, we'll say, negative 5th. Okay. Now, in order to add these together, what has to be the same? Everybody, what has to be the same? This and this have to be the same, don't they? Okay? So how can I get those to the same? I can move negative 7 up to negative 5. Do you understand why it's up to negative 5? Because they're what? Because they're negative. Okay?
You said that was a 4.
Did I say a 4?
Yeah.
Okay, fine then. We'll make it a negative 4. So I need to move negative 5 up to negative 4, right? And the reason it's going up is because they're what?
Negative.
Negative. Or we can do it the other way. Okay, which one do you want to do? Olivia, which one do you want to do? Up. You want to do negative 4 or negative 5? Okay. So you want to go to negative 4. So if I'm going to move negative 4, this has to go where?
Down 1.
This has to go where?
Down 1.
This has to go where?
Down.
Keep saying it. This has to go where? Up. Okay, guys, you're at negative 4. I mean, negative 5. I need to get to negative 4. What do I have to do? I got to go up. Okay, so if this is going up, where's my decimal going? Left. Okay. So is anything happening to this one? This is staying the same, right? 7.1 times 10 to the negative 4th. Okay, plus, now if I go up to negative 4, okay, I'm going to move this decimal where? One place where? To the left. Why? Because my exponent went where? Up. Okay, so this is no longer 4.9. If I move this one place, what does this become? 0.49. Okay, now let's add this plus this. If you add 7.1 plus 7.49, what do you get? 7.5 okay, times 10. Now, because I have the same denominator, what am I going to do with that? Just what?
Keep it.
Just write it as the common denominator. Okay, that's my final answer. Okay, does that make sense? Yeah? Question.
So down below, then you add them and not multiply them. So like.
Right here?
Yeah.
Yeah, you just add these together. Because the sign that's separating the two scientific notations, this is a plus sign.
Okay.
Okay? All right, so what if it's a subtraction sign? Okay, let's try one like that. Let's say I've got 3.57 times 10 to the second, and I'm going to subtract 1.7 times 10 to the first. Okay. Well, what's the problem here? What's the first problem that we can identify here? Well, this is this multiplication or division? Is this multiplication or division? What is it? Subtraction. And in order to add or subtract, I have to have the same what? Exponent. Okay. So, do you want to go up to 2 or down to 1? Smear. We're going to go up to 2. So what happens to this one? This one stays what? Exactly the same. This stays subtraction. Now this exponent is going to go up to 2. Well, once again, if I go up, where does my decimal go? If I go up, where does my decimal go? Left. So this went up to 2, therefore this decimal moves this way, right? So what does 1.7 become if I move the decimal one place left? 0.17. Okay. Now I have 3.57, but what's the sign between the two? Subtraction. So I say 3.57 minus 0.17. Okay, and if you do that, what do you get? 3.4. Okay, and then the exponent is the same for both of these, so I have times what? Times 10 to the second. Okay? Question.
Let's say you wanted to go down to 1, would it be the same answer?
Yeah, I'll show you. If we didn't, I'll do it in a different color so you can see what would happen if we went down.
I'm
Okay?
just curious if you like have to do it the same way.
No, I'll show you. Watch. If I went down to 1 on this, okay, if I go down, my exponent goes where? This way, right? I mean my decimal. So this, if I moved it down, would be 35.7, okay, minus, well, this is, we'll just say times 10 to the first, okay, and this would be minus 1.7 times 10 to the first, right? Well, if I do 35.7 minus 1.7, what do I get?
3.57.
34.0,
Oh yeah.
right? Times 10 to the first. Well, in order to change this back to scientific notation, what am I going to have to do? I'm going to have to move it, right? So this would be 3.4 times 10 to the second. Okay, did I get the same answer?
Yeah.
Yes. Okay. So it's really up to you. It's, to me, you have to move it less at the end when you go up to the same exponent. Okay? Jackson, question.
I don't get the whole thing in general.
You what?
I don't get the whole thing in general.
You don't get the whole thing in general. Okay. I'm going to write one up here, and you specifically tell me what you don't get. Okay? I have 2.3 times 10 to the fifth, and I'm going to subtract 1.4 times 10 to the second. Okay. All right.
Is that a 5 or an X? That's not a 5, it's an X. You never know.
Okay, so Jackson, in order to subtract these, what has to be the same? Exponents have to be the same, right?
Yeah.
Because this is not multiplication or division, right? Right?
Yeah.
Yeah. So do you want to go, let's take this 2 and move it up to 5, okay? So this one stays the same. This is 2.3 times 10 to the fifth, okay, minus, now this 2, if I'm going to go up, my decimal has to go this way, right? So if I go 2 up, how many to get to 5? I would have to go up 3. Therefore, my decimal, this went up 3. My decimal is going to move to the left 3. Okay? So this, if I move it 1, 2, 3, what's that going to be? 0.0014 times 10 to the 5th. Okay. Do you understand what we did so far? Yeah. Okay. Now, all I have to do, because this is subtraction, I'm going to take this 2.3 and I'm going to subtract 0.0014. Okay? So let's do 2.3 minus 0.0014. Okay, do that. 2.3 minus 0.0014. And I have 2.29, and we'll stop there. 2.29, right? Okay. And then my my exponent is 5 on both of these. Because it's subtraction, it just stays a 5. And this is my final answer. Okay. Does that make sense now? Okay. So if it was addition, what would I do differently? You would add these two numbers instead of subtracting them.
Wait, how'd you get the 10 to 5?
How'd I get the 10? I moved this exponent up to 5. Because these have to be the same in order for me to add or subtract them.
Did you add them later after you add those things?
You mean, are you talking about this 5?
Yeah.
This one just stays the same. It's like the denominator in a common denominator. It just stays 10 to the 5th.
This is the 10 stays the same. The exponent is the same too.
Yeah. Question?
So you move the 2 up to 5 so that
Uh-huh.
they match, and then how many times it takes 2 to get to 5 when you move the decimal,
Mm-hmm.
and if you move it up, sorry,
That's
if
okay.
you move it up,
My decimal goes left. If I was to move this 5 down to 2, then my decimal would go to the
if you
right.
were to move it to the right, would it be a negative?
Not necessarily. I mean, if I move this 5, let's say I wanted to get the 5 down to 2. Okay, if I went down 3, then my decimal on this number would go to the right 3. Okay? But it's easier just to get them to the same number.
That makes sense.
Okay? All right. You want to do one more, or are we good? Okay.